morning everybody, happy Wednesday. So today we're going to be moving on to looking at our next part on capacity. We're going to be starting off by doing a bit of a recap first of previous learning, and then we'll be moving on to looking at our next activity. So for our flashback for today, I would like you to have a go at doing these questions. So pause the video to have a go to tell me first of all what the shape is at the top, then to have a go at the ordering fractions in descending order. So remember thinking about what ascending is and then what descending is and thinking which way it will be. Then for number 2, you're going to compare the fractions using less than, greater than or equal to. Now have a look at those because the denominator is different, but think about what that could mean because the numerator is the same. Number 3, calculate 3/4 of 84, so you're finding a fraction of an amount. And number 4, you're multiplying 23 by 4, so please use your column method to work it out. So pause the video now, have a go at doing those questions. If you're unsure on one, just leave it, that's absolutely fine, because I will go through how to work it out and show you the answers after. Okay, so having a look at the first shape, we can see that you should have said that the shape is a cuboid. Now the reason why it is a cuboid is because we can see that there are rectangles and there are shapes because squares on this shape, and we know that it is a 3D shape because it is more like a box, and it is obviously not a cube because a cube only would have squares on it, whereas obviously the cuboid has rectangles as well. So well done if you've said that the shape is a cuboid. Okay, let's have a look at number 1 then. So ordering the fractions in descending order. Now in order to do this, we can see that the denominators are the same. So I have drawn a bar model here to show a bar with 15 parts. Now remember, I know there are 15 parts because that is my denominator. So I'm going to do it in descending. Now remembering, descending means going down, so D for down, whereas if you're ascending, if you're a rocket ascending, it means you're going up. So if we're going to be going down, that means we must start with the biggest fraction first. Now because all the denominators are the same, we can look at our numerators. Now we can see if I was to draw these 3 bars, it would look something like this. So if I now shade in, so if I've got 11/5, so I would do 15th, sorry, 4, 5, 6, 7, 8, 9, 10, 11. If I had 2/15, I would shade 2 in, 1, 2, and if I had 8/15, I would shade 8 in, 1, 2, 3, 4, 5, 6, 7, 8. Now looking at this, we can see that which one is going to be our biggest. Which one is the biggest amount, which has got the highest amount shaded? It's going to be 11/15. We then know our next one is going to be 8/15 because that's our next biggest fraction. And finally, my last one will be 2/15 because that's my smallest fraction. Now, because they all have the same denominator, because we are starting with the biggest number and we're going descending, we're going down, we could have then looked just to see which was the biggest numerator and made them into smaller ones. Okay, looking at question 2, so we had to compare the fractions using less than, greater than or equal to. Now, in order to do this, we could have either drawn our bar models, so we could have drawn a bar model to show what 1/12 looked like and what 1/3 looked like, which I'm going to draw that now. So it looks something like this. So we can see that I've got parts which are 12ths and parts which are thirds. So I can, because obviously the denominator tells me the number of parts. Now if I shade in what 1/12 would be, and if I shade in what 1/3 would be, we can see that a third is bigger than a 12th. Now the reason for this is because the numerators are the same, the smaller the denominator, the bigger the fraction. So I would say the third is bigger. Now if you imagine that these are chocolate bars, if I had a chocolate bar and I was sharing it between people, if I was going to give everybody 1 piece each, if I was sharing it between 12 people, you would have a smaller amount of chocolate, whereas if I was sharing it with 3 people, you would have a bigger amount of chocolate. So anytime you're comparing, if they've got the same numerator of 1 and I'm looking at the denominator, the smaller the denominator would mean you would have more chocolate. It would be a bigger part. Okay, number 3. So this time we're calculating 3/4 of 84. Now this is quite a difficult one because it's using a big numbers and we're trying to find a fraction. Okay, so we're going to have a look first of all. Now when we find fractions of an amount, remember we need to first of all decide what we're dividing by. So we've got our total number of 84, and because we're finding a fraction of amount, we want to divide that by the number of parts. So our number of parts is 4. So I could either draw 4 circles, but if I was going to dot 84 times, that is going to be a lot of dotting. So what we could do is we could partition our number 84 into 2 numbers. I could do it into 80 and I could do it into 4 because 80 add 4 is 84. Now I'm going to divide each of these, so I'm going to do 80 divided by 4, and then I'm going to do 4 divided by 4. Obviously still 4 is going to 8 is still quite a big number, but if we take off the 0, how many 4s go into 8? Well, let's count it. 4, 8, that's 2, and put my 0 back on. I can then do how many 4s go into 4? Well, I know 4, so it's only 1. So then if I add these two numbers together, 20 add 1 is 21. So I know that in my 4 parts, so if I draw my 4 parts now, I'm going to have 21 in each part. But if you have said that 21 is the answer, you are incorrect because 21 just tells me what 1 part is worth. So 1 part is worth 21. However, if we look to see how many parts, what my numerator is, I want to find what 3 parts are worth. So I can circle my 3 parts, or alternatively I can do 3 times by 21, 20, 40, 60, 61, 62, 63, so I've done my 10s first and then my 1s, and I can see that my answer is going to be 63. So if you got to the answer of 63, fantastic, well done. Now before we move on, I'm going to give you another question like this with it using a bigger number so you can have a practice. Now that you have seen how I have worked it out, you can then have a go at doing it. So please can you have a go at doing this question? So can you now show me your working out to find out what 2/3 of 69 is going to be? Once you have got your answer, remember we want 2/3 not 1/3, play the video and we'll see if you have got it correct. Okay, so we're going to go through the answer now. So we want to know that there are 3 parts, so I'm going to be dividing by 3 because there are 3 parts. And I know my total number is going to be 69. So I'm wanting to do 69 divided by 3. However, that's a lot of numbers to dot into your circle. So I'm going to partition my number 69 into 60 and 9. You could have done 30 and 39, you could have done other numbers as well, but I've just picked a nice easy one. So then I'm going to divide 60 by 3 because that's my number of parts, and I'm going to do 9 divided by 3 as well. Now 3's into 6 is quite difficult, so let's take off my 0. How many 3's go into 6? 3, 6, my answer is 2, but I need to put my 0 back on because I've taken it off. How many 3's go into 9? Well, there's 3, 6, 9, so it's 3. Now if I add these two numbers together, 20 add 3 is 23. So I know then in each of my parts I'm going to have 23. However, I know that 1/3 is going to be worth 23 because that's how many is in 1 part. But if I look at my question now, I want to know how many is in 2 parts. So I could either do 2 times 23 because I want to know what 2 lots of 23 are, or I could do 23, add 23 to get 46. So if you have got the answer 46, you have got that correct, so fantastic. Finally, for question 4, we want to do 23 times 4. Now in order to do this, we're going to use column method. So I'm going to write H, T, O, I'm going to write 23 in my 2 in my tens column, my 3 in my ones column, my times sign, and I'm timesing it by 4 ones, so that will go in my ones column. So that you should have set it up like this. Now remembering we always start in our ones and we're doing 3 times by 4. So if I do my 3 times tables, 3, 6, 9, 12. Now remember we can't put 12 in one, we can't put 2-digit number in our column, so we would need to exchange 10 ones for 1 10. So my 1 would go under my tens column and my 2 would go in my ones column. So we can see that it says 12. Then I'm going to go into my tens column and I'm going to be doing 2 times by 4. So 2 lots of 4 are 8. However, don't forget to add your extra 1, which would be 9. So you should have found that the answer was 92. Now I'm going to give you 2 more questions like this and for you to have a go at doing before we move on to today's task. So I'd like you to pause the video now and I'd like you to have a go at doing these 2 number sentences and show me your column method just like we've just done to work it out. Once you've had a go at doing that, press play and we'll see if you've got your answers correct. So you should have set it up something that looks like this. So for number 1, I've done my column method. So again, I'm going to start in my ones column. 5 times 4 is 20. So I will exchange my 2 20 ones for 2 10s. So my 2 would go in my tens column, and my 0 would go in my ones column. So that says 20. Then I would do 3 times 4, which is 12. Add your 2, 13, 14, and again I would need to exchange because I can't put 2 digits in one column, so my 1 would go under my hundreds column to represent 100 and my 4 would go in my tens column. Now I've got nothing times 4, which is nothing, so I just need to add my 1, so the answer should have been 140. For the second one, 8 times 3, if I do my 3 times table or my 8, I could do an 8, 16, 24. And my 4 would go in my ones column and I would exchange 20 ones for 2 10s. So again we can see it says 24. Then I would go into my tens column and I would do 4 times by 3, which is 12. Add my 2, which is 13, 14. Again I can't put 14 in one column, so I would exchange 10 10s for 100 and I would put my 4 in my tens column. So again I can see it says 14 and then nothing in my hundreds. Times by 3 is nothing. Add my 1, which is 144. So if you've got both of those correct, fantastic. Okay, so quick recap. What do the words capacity and what do the words volume mean? Well, capacity means the amount of liquid or amount of something that an object can hold, whereas a volume means the amount of liquid that is in the object. So, for example, the capacity of a jug might be a litre, but there might only be 400 millilitres of volume of water inside it. So this was the example. So the capacity is 100 millilitres of this jug, and the volume is 60 millilitres because that's how much water is in it at that time. So when we were looking at millilitres and litres, we knew that there are 1,000 millilitres in 1 litre, or in 1 litre there was 1,000 millilitres. So quite similar to when we were looking at grams and kilograms, there is 1,000 in each. So I'd like you to have a look at having a go at doing this one. So first of all, tell me what the capacity is, so how much is the maximum amount of liquid that could be in this jug. Then work out the increment. Remember, the increment is the number, the scale that is going up, so working out what each little line is worth, and then working out what the volume of liquid is. So I'd like you to have a go at doing this now. So pause the video, have a go, and then I will show you how to do it. So let's have a look. So we know that the capacity is the maximum amount, so we know that the capacity would be 50 millilitres. Now, when we're trying to work out the increment, we can see that it's going up in millilitres. So first thing we need to look is it's going up in millilitres. So I know that whatever I'm going to count up in has to be in millilitres. So I'm going to start from 0, and because it says 25 there, I'm going to start in ones, and I'm going to see if it's going up in ones. So 0, 1, 2, 3, 4, 5. Oh, that says 25, so I need to go bigger. So let's go 2s. 0, 2, 4, 6, 8, 10. It's going to be bigger than that. So let's go up in 10s. 0, 10, 20, 30, 40, 50. It's too big, so I need to think of a number that is between 20 and 50. I'm going to go for 20, sorry, not 20 and 50. Between 10 and 2. So let's have a look at 5. 0, 5, 10, 15, 20, 25. So I know that each of these little lines is worth 5 millilitres. So my increment is going up in 5 millilitres. So now I know that it is going up in 5 millilitres. My waterline goes up to here on my diagram. So I know that there, if I count it up, I've got 5, 10, 15, 20. So my volume is going to be 20 millilitres. So I know the answer is going to be 20 millilitres. I'd like you to have a go at doing this one now. So what is the capacity and what is the increment to work out what the volume is of the liquid on here? So I'd like you to have a go at doing it, working it all out, and then tell me the answers, and then I will go through the answers after. Okay, so let's have a look. So I know that my capacity is going to be 500 millilitres because that is the maximum capacity that is in my jug. So I know my capacity is going to be 500 millilitres. Then I need to work out my increments. Now I can see that the big numbers are going up in 100, 200, 300, 400, 500. However, we need to know what each of these little lines is worth. So if I start from the bottom and count up in ones, let's see. 0, 1, 2. It's too small. Let's go up in twos. 0, 2, 4. Still too small. Let's go bigger then. Let's go up in tens. 0, 10, 20. That says 100, so it's still not right. So we need to go even bigger. So let's go 25s. 0, 25, 50. Still not quite right. So let's go up to 50. 0, 50, 100. So I know that each little line is going to be worth 50 millilitres. So now I know that they are going up in 50s. If I can't count in 50s, I can count in 5s and take off my 0. So I'm counting 50, 100. So my volume would be 150 millilitres. Again, like I've just said, if you can't count up in 50s, we could do 5, 10, 15, and then put your 0 on to find 150. Okay, I'd like you to have a go at doing this one next. So what is the capacity, what is the increment, and what is the volume? So pause it now, have a go, write it down. The capacity is, the increment is, the volume is, and then play it once you know the answer. Okay, so I can see that this time my capacity is going to be 1000 millilitres. And remember, I know that 1000 millilitres is also the same as 1 litre. Then I want to work out the increment. So I can see that the full, at the top it's 1000 millilitres, halfway down it is 500. So I need to work out what each of these little lines is worth. Now let's start. Now because it's a 500 millilitres in the middle, I know that it's probably not going to be going up in ones or twos. So let's start from a bigger number. Let's start from tens. 0, 10, 20, 30, 40, 50. Doesn't quite work, but if we notice that I got to 50 and that was 500. So instead of counting up in tens, I could count up in hundreds. Let's try that. 0, 100, 200, 300, 400, 500. So I know that my increment is 100 millilitres because that's what they are going up in. Now I need to have a look to see how much my volume is. So what volume of liquid have I got? I don't need to start at the bottom. I know they're going up in hundreds, so I could start from 500, 600, 700 millilitres. So that would be my volume. Okay, the next one, can you tell me what the capacity, the increment and the volume is? This one is a little bit more difficult, so please have a go at doing it really carefully to work out what the increment is first before you tell me the volume. Okay, let's have a look. So again, I can see that my capacity, the full amount that could go in will be 1000 millilitres. I can then see that all my big numbers are going up from 0, 250, 500, 750, 1000, so they are going up in 250 millilitres. However, we need to work out as well as what the little lines are worth. So let's start from the bottom. Now, because I'm going up to 250, I'm probably not going to be counting up in ones or twos because that's going to be too small. Or fives. So let's start with tens. So 0, 10, 20, 30, 40, 50. Doesn't quite work, so I'm going to need to go bigger. Let's try 20s. 0, 20, 40, 60, 80, 100. Still not quite big enough. Let's go 25. 0, 25, 50, 75, 100, 125. Still not quite big enough, so let's go bigger. Let's go 50. 0, 50, 100, 150, 200, 250. So I know that my increments are going up in 50 millilitres. So now I know that I can work out what my volume is. So my volume is 0, 50, 100, 150 millilitres is the volume. So well done if you got those correct. Okay, so now we're going to have a look at this one, and we're going to have a look to see where we would draw our where it would fit. So I can see that from this that the increments I need to work it out first. So I know that there's 100 millilitres, which is 1,000 millilitres. So I'm going to count up to see what my increments were going to be. So I'm going to put my finger on the screen. I'm going to count up. Because I'm going up to 1,000, I'm going to try counting up in 100 to see if that one will work first. 0, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So that works. So I know that each of these are going to be, I know the increment is going to be 100. So the little line will be 100, 200, 300, 400. So if I have a look to see where 350 will be, now I know that between each line is 100 millilitres. Now I know if I do 100 divided by 2, or half of 100, I know that that would equal 50. So I know that halfway between each increment, each 100, there will be something 50. So, for example, it would go 150 if it was between 100 and 200. So if I want to find 350, I first need to go to 300, and I need to find halfway between 300 and 400 to show that it would be halfway between it. So my waterline would go up to about there. Now, I've got 625, so I'm going to keep going. So I've got 500, 600, 700, and I'm only going to go up to 700 because my number is between 600 and 700. Now I've got 625, but if I know that 50, I know 50 is half of 100, and if I do half of 50, so 50 divided by 2, it would be 25. So I know that this is going to be a quarter. So I know that my line, my water line, it's not going to be halfway between 600 and 700 because that will be 650, but it's going to be then halfway between 650 and 600. So it will work out about approximately about here on your water line because it is half of it's halfway between 600 and 650. So you should draw it about there. So we're finding an approximate. So it might not be exactly right, but we can have a guess because we know that half of 100 is 50 and half of 50 is 25. So I'd like you to have a go at doing these questions now. So you're going to be saying how much is in the jug. You're going to be drawing on the jug, answering the questions to find all the answers out. Now these are on Seesaw, so please do have a go. Also then put your answers on Seesaw and please mark them, which I'm going to go through the answers next. So please have a mark of them to see if you've got them all correctly written, and then put them on Seesaw after. So let's have a look at the answers. So number 1, how much is in the jug? So in A, we can see that we work out the increments are going up in 100s, so it would be 600. For B, we can see that they are going up in 100 millilitres are the little lines. So if I count up from, I know there's 2 whole litres, so it'll be 2 litres. And if I count up in 100 millilitres, that there will be 600 millilitres. Part C, again they are going up in increments of 100 millilitres. So again I know I've got 1 full litre, so 1 litre, and I have got 900 millilitres. Again you could have taken off 100 from the next litre to find out that there will be 900. And finally, the last one, again, we're going up in 100 millilitres. So I've got 3 full litres and 200 millilitres. Now you had to use the capacity in the bottle to show where this was on the jug. Now you have to be really careful to see exactly where they are. So if you pause the video now, see if you have got yours accurately written. Remember, you had to work out the increment first before you could actually draw this on. For number 3, you had to say how much water was in the container. In the first one, we can see that they are going up in 200 millilitres. So it will be 400 millilitres in part A. For part B, we can see that again they're going up in 200 millilitre increments, so it will be 2 whole litres and 400 millilitres. Part C would be 4 litres and 800 millilitres, and part D would be 3 litres, but this time the increments are going up in 250s, so we can say it would be 3 litres and 250 millilitres. Mo has some orange juice in a jug. He pours it into another jug. Draw a line. So because the increments are different, we can see that first of all we should have worked out how much was in the first jug, which we should have worked out that there were 2 litres and 800 millilitres, so that when we had a go at doing it on the other jug, we first needed to work out what the increments were going up in. They were going up in 200 millilitres, so this is where your line should have been drawn. So even though it looks like there's less orange juice, because the increments are going up higher or in bigger amounts, obviously it looks like there's less in there. Different bottles hold different liquids. Who has more liquid? So you first of all had to add all the liquids together. So in Dexter's he had 1 litre and 750 millilitres. And in Eva's, if we add them up together, she also has 1 litre, 750 millilitres, just because they are different bottles, so they have the same